Okay, so I'd like to invite Dr. Rodger Voelker, our lab director at OG Analytical, to come up and tell us a little bit about analytical variance.
Hey everyone, thanks for coming. And just remember, if you're going to bring bacon, take it to Jeremy because he's going to be validated for it, okay? Just remember, send your bacon that way. Anyway, yeah, thanks Jeremy for touching on it because the reality is that what he touched on there is really, there's just truly a lot of complexity under the hood behind doing analytical chemistry, and that's those are the challenges that I think people like us enjoy. But the simple fact is that it is quite challenging, and that's it's interesting to me. I've been an analytical chemist for a long time. I quite honestly have never had as much public interest as in this industry. So whether you like it or not, you guys, I think it's because in a sense, the lack of accreditation and things like that has led to sort of a buyer beware market. And so what we find is people have to educate themselves, but that's a good thing, and because what you're learning here actually applies to the whole world of commodities. Okay, really what we're talking about with things like accreditation, that's just simply the same process that is already put in place on other labs testing other types of commodities. And so really what you learn here applies to most of the rest of your world. So anyway, I'm hoping I can educate a little bit more on really one of the most, I have to say it's one of my favorite aspects of analytical chemistry and one of the central principles, and that has to do with this concept of precision and accuracy. And I'm not going to go into the stats, so for those of you who wanted that, I'm sorry, but I'd love to talk about that stuff. So I'm going to just try to touch on stuff, and I hope that you get some interesting questions. Okay, so arguably this is probably the single most common question that we get asked. Not usually explicitly, but somebody brings you a flower, a cured cannabis flower, and this is effectively the question that they have. How much THC is in my bud? So, and again, this has actually now come up twice already, but so then the question that I was curious to get feedback from people also was, what your general perception is of what range do you expect? And so what is the average amount? So obviously we've sort of hit on this, but what I am curious, so again, the answer, I will tell you, OG Analytical, our mean, our average is like 18.4. The average for the total THC in the state of Washington is something very, very similar. Some data I found coming out of Denmark, very, very similar. But I have continually been confused because I see on the market an awful lot of flowers that have much higher values. Now, has anyone else noticed that? I mean, have you wondered about that? Because, it's been mystifying me. So all I can say is that whenever the Cannabis Transparency Project came on, I was greatly relieved to see that, in fact, the values that we are producing are actually very comparable to what, sort of accredited labs with some level of oversight are producing. And in the following talk, we're going to hear some more about that, but I think we have a stand to gain a lot from, again, about this concept of making some of this data transparent. Okay, so now let's get down to one of the other things that's come up quite a bit. So somebody has a flower sample, and and quite honestly, I'm sure most of you people here who are in this market have done this because you're shopping around for a lab, and so you're going to submit that to 3 different labs. Will you get the same answer? Did you expect to get the same answer before you did the experiment? So, why or why not? I mean, Those are some of the things we want to talk about here. But that raises an important point, which is, okay, so you did that experiment and you actually had enough, knowledge and general understanding that you didn't expect to see the same value. But then, and so let's say that, these are your values that you got, between these three different labs. Now, you just sort of said, well, I didn't expect the same answer, but is this level of variance acceptable? How do you know? How do you know? How do you know that? Your gut is probably telling you that, but is there anything else that's telling you? Well, I don't know, but that's just it. There are factors at play here, okay? And so let's just hold on to that for now. So, but let's keep in mind that this is a really critical question. It turns out to be actually a very difficult question to answer. But there are some beautiful statistics, actually, that you can plow through and get a really good estimate of that answer. We won't do that today, but I'd love for somebody to ask me about it. Okay, so now we're going to do a slightly different experiment. You brought me 3 samples, and you went ahead and you were really sly, and you named them 3 different things. And so you want to see, essentially you want to get a measure of my repeatability, or my precision. So will you get the same answer? Again, I think most people would. What was that? It should be closer. Same lab, 3 samples, but I don't know that they're actually from the same set of flowers. Okay. So again, the sort of suggestion is that you're not going to get the same answers or the exact same value, but now I am curious to get some more feedback. Does anyone have any ideas, like what would contribute to variability here? What's that? Variance within the sample, so like biological variability? Yeah, absolutely. Well, presumably I analyzed them all the same. Like I could even run them on the same day. But, well, there could be errors, which are often referred to as systematic biases. But in reality, there's also a fundamental underlying just variability in the universe. So, there's a randomness at play as well. And so again, the real question becomes, where'd my question go? Anyway, the real question becomes, what is an acceptable level of variance, right? That's really one of the key things that we have to deal with. I went the wrong direction. That's what's going on here. Okay. So before we get into that any further, first of all, I want to clarify something because, this may seem extremely trite and mundane. It happens to be really an astounding principle that we take for granted in our day-to-day life, but it's really important to understand. So essentially, there's 2 basic types of measurements that can be made. One is what's often referred to as counting or enumeration. So that's it, how many quarters in my pocket or how many bottles of beer in my fridge. Well, in that case, there's an exact number, right? You count it and you get an exact number. There's no equivalent of variance or randomness or anything like that. However, there's other types of measurements that we deal with continually. And so, for instance, how fast am I driving? You look at your speedometer. Well, do you know exactly what that is, what the value is? Or how much do I weigh? Do you stand on a scale and know exactly how much you weigh? So these are a type of variable, and then also how much THC is in my flower. This is a type of variable called a continuous variable, okay, versus a discrete. Turns out this is where it gets complicated because of this continuous variable. So it turns out that in these cases, we arguably have some sort of a true value, but I can argue that we can never know the true value because we can never measure it accurately or precisely enough. The entire game of, I would say, analytical chemistry and much of statistics is we're estimating the true value. Okay? We're accepting the fact that there is variance. Our estimate is always limited by our precision and our accuracy. And I'll show you what that means in a minute. So again, probably a lot of you have seen this sort of way of depicting accuracy and precision using the bullseye, but quite honestly, it's one of the best depictions of it that I'm aware of. So these are two really important terms, accuracy and precision. So accuracy is a measure of how close whatever measured value is to the true value. And precision is how widely do those individual measurements differ from each other, okay? With these two sets of parameters, really, you can end up with 4 different scenarios. In one case, imagine that again, the bullseye, and these are the, I don't know, bullet holes or whatever. So this is a case we have low accuracy and low precision. Okay, they're scattered, and none of them hit the bullseye. They're not even close. In this case, we have high accuracy but low precision. Now this is a little bit nuanced. Why do I say it's high accuracy? Well, because the average of all these was essentially the bullseye, okay? But it's really low precision, so there's a lot of variability. In this case, we have high precision. They all saw the same spot, but they all missed the mark. This is really what we want. So this, in this case, if we think about this as, again, as a measurement, this is a situation, this is what we're shooting for. So it's really in the world of measurement in general, you are striving for high accuracy and high precision. The simple fact is, we all live in this universe. This universe has randomness. And on top of that, there's a lot of other parameters at play. But the simple fact is, every measurement you make, other than enumeration, contains some level of uncertainty. Now, some people who like to rile people up or something, we refer to this as error. Actually, scientists refer to this as error all the time, but we are well aware that in this case, error does not imply some sort of mistake. So I prefer the term uncertainty. They essentially mean the same thing. It's just it's this variable component where we don't know. There's some component of this thing we measured that we don't actually know. So really the important questions then, are, first of all, a little bit of understanding. Why is there uncertainty? I'll show you an example in a minute. And again, how much uncertainty is acceptable? How do we minimize it? And actually, really importantly, in order to deal with that one, is that you actually have to know how to quantify it. So again, in our day-to-day life in Analytical Lab, we spend, I would argue, most of my time is spent dealing with questions like this. Okay, so why is there uncertainty in measurements? Well, it's one simple example. All measuring devices have some limit to their precision. So for instance, if I was going to measure the same object, let's say I have, I want to measure the length of a bolt or a screw. I could use this yardstick where I have, it's broken into, it's a metric, and so I've got centimeters, but I only have a single division line in between. So I'm going to be, if it comes somewhere in between, I'm estimating that, right? I could use this one, which has thousands of little teeny fine lines, get a much more precise measurement. And then I could use a caliper where I could get an extraordinarily precise measurement. Okay, so I know this seems trite, but this is actually really critical. Again, in your day-to-day life, you might not have to think about this a lot. We have to think about this all the time. So, but the bottom line is that your precision is limited immediately by how you did the measurement. There's actually a lot more things involved but immediately the instruments you use play a critical role. So if we want to maximize our accuracy and precision in chemistry, again, we're going to try to use high precision instruments. I really like this. It's really cute. And actually, now that I found this on the internet, I want one of these. My daughter would love it, and I just think it's awfully cute. But it's inappropriate for a lab. Instead, we use many $1,000 analytical balances. So if you're measuring liquids, for instance, again, these types of devices are absolutely fine in your kitchen, but they are inappropriate in a laboratory. Instead, we use high-precision syringes and glassware. And of course, when it comes to the instruments, labs do have to spend money to get high-precision instruments. It's a simple fact. The difference, you very much get what you pay for. So just really quickly, just to sort of put some perspective, let's just talk about how do we measure THC in a bud. Well, again, as Jeremy sort of touched on, first we're going to grind the sample. And it's really important that we grind that sample. We're going to already assume that that sample represents multiple flowers, so I'm not going to get into the heterogeneity there. But once you bring it to the lab, I need to grind it up and make it extremely homogeneous. So I can take a small portion and it actually represents the average. So that means grinding it into a powder. And I will say this is a bit challenging to get this right each time. Then you weigh a portion of it with a high precision balance, and this is a subsample of this. Then again, you add a very carefully measured amount of solvent. And critically, this is something that you never do in your day-to-day life, but you try to do in a lab at multiple steps. At this point, you hopefully are adding some sort of an internal standard. An internal standard is some chemical that behaves similarly to the chemicals you're measuring, but it isn't one of those chemicals. And I added a known amount. And now the key is I can monitor this all the way through, and that'll tell me if something happened. There was some mistake in the pipetting, there was some mistake on the instrument or something, right? Because stuff can happen. So then we were going to soak and sonicate it to solubilize the THC. And then again, we make a careful dilution. And again, the accuracy that we can actually monitor by monitoring our internal standard. And then we're going to analyze it. In this case, I'm going to say we're going to analyze it via HPLC, although we can use GC, and I'll touch on that in a minute. Now, what are some of this is where we're really making we actually made a bunch of measurements I just talked about, but now we're making our really critical measurement. In this case, this is again something that you probably don't do in your normal life, but how do we measure it? Well, you get a response, you get a peak, and you get a peak area, and I should have shown an example of that, but anyway, so how I use that to tell me how much THC I had is via what's known as a calibration curve. So a calibration curve is made by injecting known, very carefully measured amounts of THC that I bought from another company, and this is very carefully measured out material. It's very expensive because of that, and it's often referred to as CRMs these are like NIST traceable standards. Okay, so the entire chain of making this is documented, and everybody involved is accredited to do this. So this is very accurate. So I can inject known amounts of that, and then hopefully I end up with a response factor that looks kind of like this, where I get a curve. This is my calibration curve. Now I get a response, and I look at where it intercepts. That's the concentration. Okay, so that's kind of what's behind that. So I want to again, use high precision instruments and use them correctly. I'm going to, again, use a minimum 5-point calibration curve, which helps maintain or increase the accuracy and the precision. We're going to use an autosampler, which is actually a robotic system to make the injection that minimizes or maximizes reproducibility, minimizes human error. And also, we're going to do another component of QA/QC. We're going to every time we do a run, we're including this, and we can monitor that over time as well, and we can identify drift and things like that. Those are some minor components of standard QA/QC in a lab. Okay, now back to the THC business. So we got some sense of how we're going to measure it, but now let's talk about this very specifically. So it turns out in this case things are a little bit more complicated, because in raw flower, again, as I'm sure almost every one of you know, most of the THC is actually present as THCA. It's got this carboxylic acid group right there. And that THCA is converted to THC upon heating. So in reality, when we say this, what we want to know oftentimes is what we call the total THC, for lack of a better term. And that is some summation of the THCA and the THC. However, it turns out that the total THC is not actually just the simple sum of these. That is an extremely common mistake I see out there, which does contribute to some of the lab-to-lab variances. That's an example of what's called a systematic error. Because the total THC, well, quite honestly, it isn't legally defined right now. That's one of the things that I'm hoping ends up in the new rules, is a legal definition of total THC. That makes sense. I will say that my interpretation and the AHP's interpretation is that the total THC is a total amount of THC that would be present if all the THCA was converted to THC. So what does that actually look like? Wait, I'm sorry, I'll get back to that in a second. Let's just keep that in mind. Okay, we're talking about, so we want to measure, again, the total amount of THCA and THC. Now, before we can go further, now we have to hit this other complication. There's two, again, most of you guys are aware, there's two primary ways of doing this. You can use a GC or you can use an HPLC. I'm going to argue that both are viable methods for determining total THC. And also, totally I'm aware, both of them have strengths and weaknesses. So let's just talk about this just really quickly. So with gas chromatography, one thing that happens is that when you inject the sample in, it's heated up, it's flash vaporized. And in fact, that heating converts the THCA to THC. So when you measure it, what you measure is THC on a GC, not THCA. So if you're careful, if you did everything right, what you get is effectively, you effectively mechanically, or I should say physiochemically did that mathematics, which I haven't really showed you the math yet, but the instrument did it. So you actually just measure THC, and it's actually the same thing as a total THC. It actually summed the THCA and THC because the THC was all converted. But, as I point out, you get no information about how much THCA was present. If it's just a flower, it doesn't really matter usually. You're just smoking it anyway. So how does it work on HPLC? In this case, the sample isn't heated, so both of those two chemicals can actually be measured independently, and that's what we do. And in this case, you're going to convert total THC, you're going to calculate total THCA mathematically. And it turns out that this is the equation where the total THCA, or THC, is the mass fraction of THC plus 0.877 times the mass fraction THCA. It's not the simple summation of these. Now, why is that? Because it's a mass fraction, and these molecules don't weigh the same thing. Molecules, you might be surprised, they're really tiny, but they have a weight. And THCA weighs slightly more than THC, and in fact, the difference is 0.877. So, I mean, I've had a lot of people have been confused, and I've heard people trying to, I think, intentionally confuse people with this 0.877 as this mysterious conversion factor. There's nothing mysterious. It's just the mass difference between those two molecules. And again, within this universe, this will always be true. Okay, it doesn't change from one lab to another. Okay, so I am going to argue that despite the hyperbole on the internet about this, a properly run HPLC and GC will give the same value within experimental error of total THC. Okay? Because I know there's a lot of people who try to say only GCs because you're heating it, and that's BS. And a lot of people say, oh, HPLC is better. They have their strengths and weaknesses. Turns out that I have preferences, but quite honestly, and the key is properly run. I think that's really what's at play. Anyway, okay, so one of the other complications with measuring THC is this issue, which actually gets very little attention, and that is the moisture content. Cannabinoids are typically reported, as it was pointed out by Jeremy, as a mass fractions or a percent weight. So for instance, 19% by weight. But are we talking wet weight or dry weight? Have you ever thought about that? You bring your flower sample in, what weight are you talking about? So it turns out, again, as Bethany mentioned, the average moisture content is about 7.1%. That's in our lab. So out of curiosity, I think it's important to look at how does this or how is the THC, what is the difference between the wet and dry? Okay, and these are real data I just gathered today, just randomly grabbed two. And so you can see that the wet weight was reported at, in one case, 19.7%, and the other one was 17.1. This one had a moisture of 7.3, this was 5.4. When you count for the moisture, you can see that the dry weight, it now has jumped up to a nice looking 20, 20 above 20. For some reason, everybody in this industry seems to be fascinated by this 20. If it breaks 20, oh my God. If it's less than 20, somehow you're a failure. I'm sorry, people. I'm going to show you why that's not the case. But it's amazing what that does. And so a couple percent makes a difference. That's one of the things that's going on also between different labs. Some labs dry samples before they analyze them. Some labs report dry weight but aren't necessarily indicating it. Some do wet weight and don't necessarily indicate it. Again, this is one of those things that has to be hammered out in rules, and we have to standardize. So, okay, back to this, the contributions to analytical variance. So again, you had the same sample tested by 3 different labs and got 3 different results, or 3 different values. So what's going on? So again, as we sort of touched on this at the beginning, some of the issues are, I would argue in reality, this is sort of what somebody said with biological variance, it actually wasn't the same sample. You may have pulled them out of the same bag, but they're not the same sample, right? They're different flowers. They may have had, there may be large biological variance even from the same plant. And so you cannot expect, it's completely unfair to expect to take the same 3 flowers from the same bag, take them to 3 labs and expect you're going to have some reasonable level. I don't actually know what the variance would be in that case, but you have to recognize that that's not quite the way to do that test. The other one is that, again, moisture content could be different. And like I said, there's differences in the way labs are dealing with that. And then again, there's different detection methods that are used. So all of these could be contributing to that. So this does leave us with the question, which unfortunately you're left with after you did this experiment. You got 3 values. Which one's right? You know, one of these was from us, one was from Jeremy, one was from somebody else. I don't know who's right. I will tell you at this point, there is no way, unfortunately, for you to know, to determine from this data alone which one is right. You can't. So what do? Well, what we do is get towards accreditation and standardization, But before, and again, Jeremy talked about that, and so I wanted to show you some examples of real-world data to give you a sense of kind of where things are right now. Again, this was from the Cannabis Transparency Project that Bethany mentioned at the beginning. And again, it provides access to all the I-502 data gathered in Washington. What I'm showing here is a distribution of the total, of the percent THCA. Again, this isn't the converted, this is just THCA in flower samples. And it turns out that the average reported is 19.3. And I don't know how many people are used to reading these types of graphs, but basically this is sort of a density plot. And so what it means is that, most of the values were reported, in this range, that's the average. And then, of course, because of variance, you see this. Now, that variance is due to both biological variance and also measurement variance. From this data alone, we cannot distinguish between those two. But what we can do is we can just simply ask, how do different labs stack up? Turns out on this website, you can select all the data from one lab and compare it against all the data from another lab. So I grabbed 2 labs, and what we see here, let's see, I gotta remember which of those lines is which. So yeah, so the line is all data, so that was a plot I just showed you. And then the bars are the individual labs. You can actually look up the labs. I don't have that covered here. But you can see, in this case, one lab, the average is 17%. Another one is 22. In this case, it looks like there's a systematic bias. There is a non-random shift in this direction. In this one, we're going the other direction. So that, again, which one is right? In this case, I'd kind of argue, now we're getting a sense of how accreditation works and things. It's sort of like, the truth is in the mean. If everybody on average is getting that, and you see that from your own lab, I would start looking carefully to try to identify potential biases. Okay, so anyway, so how do we guarantee accuracy and precision? Again, through the reality is that compliance regulatory testing labs normally all must be accredited. Unfortunately, that's not the case in this industry at this point. However, the bill was signed. So we're looking forward to the future where we will all have to be accredited, and then hopefully everybody will be better served. I'm not going to go through this, but again, because Jeremy touched on this, but basically there are very rigorous procedures to go through accreditation to get accredited. It's not trivial, and it does scare me, I will admit that. But I'm looking forward to going through the process. Anyway, with that, I'll take any questions.
Okay, so as far as biological differences with the same plant that's from a clone, most of these are all the same DNA because they're carried over by clones instead of by pollination. So my question is, well, it probably maybe has something to do with differences of the nutrients, the way they're grown, that's going to determine maybe the potency?
Yeah, I mean, quite honestly, I think there's an awful lot of people here who could answer that question better than me. I don't grow cannabis. I don't know anything about it, but I certainly would speculate that even that, although, like you're saying, what you're alluding to is the fact that there is, I think, clearly a genetic component to the total THC, to the yield. However, on top of that, there are other factors at play, environmental factors. What proportion is environmental versus genetic, I don't know. But I think that is an interesting question.
Hi, I'm Elena Sahanik. I'm MX Biotech's clinic director. And I'm curious to know what I would argue that how much THC is completely irrelevant because individual biology and major medical conditions are going to need quantified cannabinoids. The 200 and something cannabinoids each contain a different, what I would call prescription. What information do you have about quantified cannabinoids and microdosing?
You're speaking of the minor cannabinoids, what are often referred to as the minor cannabinoids, not in disrespect. It's just the THC and CBD are the most abundant. So you're referring to the other, like CBC and THCVA and all those?
I'm talking about the 243 different cannabinoids found in various plants.
Yeah.
We have certified growers who are growing not according to THC content, but we need those growers to grow according to specific CBD ratios because microdosing is the way to actually, and I'm going to call it cure the disease. And that's only because I've witnessed so many medical miracles over the last 4 months interning with MX Biotech. And it seems like you, in your presentation, said a lot about how you don't really know and there's no real data and you've got a line going from down to up as far as THC can go from low to high. But CBDs are also being measured. People are saying, I'm going to take these high cannabinoid producing plants, I'm going to buy high CBD, as in people's dispensaries are going to be selling more of the high CBD to people maybe with post-traumatic stress or something. But what they're doing actually is they're taking a whole bunch of keys and throwing it at a neuroreceptor and expecting it to fit. Whereas if you take the specific cannabinoid and put it in the neuroreceptor that it's asking for example, if you're having a REM sleep triggered seizure, you are going to need a specific cannabinoid for that seizure at that specific time. So in all of your THC research, what is it that makes, do you feel like you have proper medication?
I don't know how to, I mean, you're referring to a lot of things. I mean, again, there's different compounds and things like that. You know, I don't know how to answer your question exactly, but all I can say is that, you know, really what we're dealing with here is that the sample has some nascent level of these compounds. And whether it's THC or THCA or THCV and actually the minor ones are much more complicated, but there's still these chemicals. And really, the question, or the issues that I'm dealing with here is the challenge of measuring those accurately, because again, I mean, ultimately, if somebody is interested in THCVA, for instance, or some of these other components, all of this still applies there. In fact, actually, it's more complicated for the minor ones because it turns out the variance actually goes up, but. So anyway, I'm sorry, I don't really understand other than that.
Any other questions? Oh, go.
I know this is kind of off topic, but the same, but we as growers, we want to get the highest THC out of our bud. When we take it to a lab, would we have the water level in that, like at 7%, or would we have it down at 6%? What would we do as growers to get that sample up, you know, I mean, be competitive?
So your question is what recommendations for dealing with moisture? Is that what you're, so.
How as growers, we're taking it to the lab, what can we do to maybe make it wetter or make it drier or something to boost that THC 1 or 2 to 3% because we need a lab report so we can sell it to dispensary or something.
I'm going to tell you the long and short of this. There is a limited time that you can get away with bringing in a flower and drying it overtly, because that's going to change. The simple fact is that moisture is a parameter. We can measure it. And when we started at OG Analytical, I pretty much said, I mean, we're going to approach this like FDA, meaning that THC is like a label claim. So in other words, you want the value to represent what's on the label that the consumer buys. So if you bring me a wet flower, I'm going to tell you the THC content on a mass basis for the wet flower because that's how you're selling it. But then quickly people learn that if they dry their sample, even though that's not what they're selling, the THC level will appear to go up. But now you've ripped off the consumer. And so, the simple fact is the way to deal with that is, we're pushing to simply have that all the moisture content is always reported, and that we establish a convention as to whether we're going to go with wet or dry weight. But the moisture content plus either of those two values will allow you to determine the other one. So, I don't know if that's exactly your question, but the bottom line is that this issue of moisture will go away. And I don't mean to be suggesting that everybody's using it in trying to misrepresent, because actually, saying your position as a grower, quite honestly, you want to compare strains to each other. Or in your question about you see variability, and maybe you've tried different fertilizers, and you want to learn which one behaved, what the effect was. Well, we want to mitigate the moisture. We want to strip that variable out of there so you can actually answer those questions more accurately. So that actually is another incentive for trying to deal with this moisture issue. One more? We'll just do one more. We got to leave time for him.
Yes, I'd like to know, what do you guys do with all the leftovers from the testing and samples?
We have an SOP, and the SOP involves destruction of the material.
Do you need any help with that?
No. If you don't come and pick up your sample, it's destroyed, often involving the sewer.
Can we do one more? One more?
Nope.
Standard operating procedure. Thanks for that.
Hi, wait. One more question. What's your opinion on using ranges as far as selling versus a specific label claim?
Yeah.
To say something is 10 to 15%, 15 to 20%, 21 to 25%.
That's a good question. And it happens to be one of my favorite topics as well. But I won't bore everybody with this, but I will say really quickly. So the question is we know there's some level of uncertainty, so what do we put on a label? Well, I'll just ask you this. Take anything that you buy in the store, take a look at the label. Tell me what you see. You generally see one value. Now, that does not mean it's exactly 15% sugar or whatever, or 10 milligrams of salt. What it actually means is that the FDA has a procedure whereby you make a measurement and you simply have to guarantee that the value on the label differs no more than, I think it's actually sort of depends on the product, but by a certain amount from the value that if it was to be tested using some validated procedure. So they allow for some variance in manufacture, but it still allow the manufacturer to have some leeway for variances manufacturer to put a single value. Quite honestly, that's what I would like to see here. I feel like it works for every single thing else that we consume. Let's just do that. The downside of that is that means I actually have to know that variance really well. Do you know how I get that variance? Do you know for that nutritional labeling FDA? That's like 12 replicates. Somebody has to pay for that. So that's where we're at with that one.
Thank you very much, Dr. Rodger Voelker from OG Analytical.